Hello everyone, welcome to Chetan Bharat Learning. In this video, we are going to cover the current affairs related to geography and environment that had been in the news in the last week. So the period that we are going to cover is from 10th of December to 16th of December. First of all, let's have a look at the issues that we'll be covering in today's class. El Nino and droughts in India. There was a news item that said that not all droughts in India can be related to El Nino. Usually we tend to relate droughts in India, the drought periods in India with the El Nino phenomena, but now that news item was saying there could be other reasons as well. So we'll be covering this topic. Then India and the Paris targets. Paris Climate Agreement is the overarching agreement that governs the actions of various nations around the globe regarding climate change. In that context, a climate ambition summit took place in the last week. We'll be covering that. Then tropical montane grasslands in Western Ghats. These high elevation grasslands of the tropical areas, they are getting degraded in the Western Ghats region. So we'll be covering this topic, and then some prelims updates regarding wildlife rehabilitation facility that will be opened in Kerala, and again some prelims updates regarding Kaziranga National Park. So this all these topics will be covering in today's class. Let us start with our first topic, that is El Nino and droughts in India. Now this news item said not all Indian droughts are caused by El Nino. Now this El Nino phenomena, it is responsible for causing erratic climatic events. For example, in India, it is associated with causing droughts. Droughts in India are invariably attributed to El Nino phenomena. But at the same time, now this El Nino phenomena does not have the same implications or same consequences around the globe. In India, in Southeast Asia region, it leads to drought-like conditions. But in South America, it leads to flood-like conditions, very wet conditions. So many erratic phenomena around the globe, they can be attributed to El Nino. So in this class, we'll be covering what's the relation of El Nino with the drought situation in India, and like what this new study says, the new study conducted by Indian Institute of Science. It says that not all Indian droughts can be attributed to El Nino. They analyzed the previous droughts situations in India, and they came to conclusion that around 40 to 50% droughts, they occurred in non-El Nino years. So what could be the factors responsible for non-El Nino droughts? We'll be covering that also. First of all, let's have a word about El Nino phenomena. What is El Nino? It's a sea surface temperature anomaly. In one of the earlier videos, I had told you about the La Nina phenomena. That is the exact opposite of El Nino phenomena. That is also an SST anomaly. La Nina is also an SST anomaly. El Nino is also an SST anomaly, but they are exact extreme opposite anomalies. What happens in El Nino is the extreme opposite of what happens during La Nina. But both of these are SST anomalies, sea surface temperature anomalies. Whatever is the normal temperature of the sea surface that is observed over a period of time, during El Nino and or La Nina events, that sea temperature experiences a change, that experiences an abnormal value. What is this change? In the normal years, now we'll be able to understand change only if we'll know about the normal situation. So what happens during the normal years? Usually, now this is the image of the Pacific Ocean. Usually around the western coast of South America, invariably in the normal years, you have cold water off the western coast of South America. And again in the normal years, off the coast of Indonesia and Australia over here in the western Pacific Ocean, you normally have warm water. This is the normal situation. Okay, in the Pacific Ocean, the eastern side of the Pacific Ocean has cold water, while the western side of the Pacific Ocean has warm water. But during El Nino years, this situation is reversed. During El Nino years, there is accumulation of warm water off the coast of South America over here, while there is accumulation of relatively colder water off the coast of Australia and Indonesia in the Western Pacific Ocean. The situation is exact opposite of the normal situation. Now, what is the implication of this thing? It is a very simple implication. Like, in order to understand its implication, if I say you that there is this water body 1, there is this ocean number 1 above which winds are blowing, and there is this ocean number 2 above which the similar winds are blowing, but there is one difference in these two cases. This ocean body is at relatively warmer, relatively higher temperature. This ocean body is at a relatively lower temperature. Warmer ocean, cooler ocean. The nature of winds blowing above the two oceans is the same. In which case do you think the evaporation would be more and moisture would be more? Of course, like, it goes without saying that the evaporation would be more in the case of the water body where the temperature is relatively higher. So the winds would carry more moisture in case of a warmer water body. And those moisture laden winds would cause heavier rainfall wherever they will strike. In case of a colder water body, the moisture would be, evaporation would be less, the moisture would be less, and wherever those winds would strike, the rainfall would be relatively lesser as compared to the first case. Now consider these two situations. Now, also, like, we know of the map, world map, that this region, this Indonesia region, it's not a continuous stretch of land. The water continuously flows from Pacific Ocean over to Indian Ocean. If this region is relatively warmer, goes without saying that Indian Ocean is also relatively warmer. If this portion is relatively colder, goes without saying that Indian Ocean is also relatively colder, relatively cooler. So now consider these two situations. In one case, in the normal years, this region, Southeast Asian region, as well as the equatorial Indian Ocean, they are relatively warm. In this case, the Southeast Asian region and the Indian Ocean region, they are relatively cool. In both the cases, monsoonal winds are flowing over Indian Ocean and they are causing rainfall in India. Monsoonal winds are flowing over Indian Ocean and they are causing rainfall in India. In which case rainfall would be more? Obviously, in the case where the Indian Ocean, equatorial Indian Ocean, is relatively warmer. So in normal years, you have relatively warmer Indian Ocean resulting in normal monsoonal rains. But in the El Nino years, because the equatorial Indian Ocean is relatively cooler, the evaporation is less, the moisture that is picked up by the monsoonal winds, that would be less. So monsoonal rains are less than normal in India. That leads to drought-like situation in India. So in India, because of El Nino, you have drought-like situations. But like I said, the impact is opposite in case of South America. This entire region, Southeast Asia, Northern Australia, India, they have deficit rainfall during El Nino years. But consider the situation over here. This South American coast is relatively warmer during El Nino. Now in this case, South America would be relatively wetter also. There would be more rainfall in this region because of El Nino. So I hope you understand what's the impact of El Nino on the rainfall scenario. But like now we come to the main study, the main points of the study, that not all Indian droughts are caused by El Nino. When the researchers at Indian Institute of Science, they analyzed the situation of all the droughts that happened in India, they came to conclusion that there had been many instances, many years when there was a drought in India, but there was no El Nino. To what can we attribute these droughts? For example, they have given an example in that in 2014, it was a non-El Nino year. Still, there was a rainfall deficit of 14% in India. How do you explain such type of droughts? We'll come to explanation later. First of all, there is also certain difference in the characteristics of the droughts. The drought which is caused by El Nino, it has a different characteristic, and the non-El Nino drought has a different characteristics. What's the main difference? When particularly, during which particular month the drought sets in and how it spreads. For example, the El Nino drought, it sets in right from the outset. From the mid-June, you get to realize that okay, this year there would be less rainfall, and this slump in the rainfall, it progressively worsens with the time. There is no going back. Mid-June, mid-July, mid-August, and the entire monsoonal season, there is dip in the rainfall. There is no recovery from the drought. But in the case of a non-El Nino drought, there is initially a decline in rainfall during the mid-June. When the monsoon strikes, there is relatively a lesser rainfall, deficit rainfall, slump in the rainfall. But then in the mid-July to mid-August period, the monsoon recovers. There is slightly improvement in the rainfall situation. But then during the last week of August, during late August weeks, there is again a slump in the rainfall, and then there is no recovery. So what's the key difference? Here in the case of El Nino drought, the rainfall declines and it progressively worsens. But in the case of a non-El Nino drought, rainfall declines, then there is a recovery during mid-June to mid-August period, and then the rainfall starts declining. So this is the difference in characteristic that you should keep in mind with respect to an El Nino drought and a non-El Nino drought. Then what's the explanation for this? In trying to find the explanation for this non-El Nino drought, the scientists wanted to empirically confirm that what difference was observed in the atmospheric situation all over the globe when India experienced a drought in non-El Nino year. And with this technique, they were able to identify that probably Rossby waves can partly provide the explanation for these non-El Nino droughts. What are Rossby waves? They are basically the name given to the meandering jet streams. In your geography course, if you have already covered the geography portion in your general studies portion, you would have covered about jet streams. And one of the key characteristics of jet streams is that they move in a meandering path. What's a meandering path? Serpentine path. What are jet streams? Let me give you a brief introduction before I move forward. Jet streams are high altitude, high speed winds moving in upper troposphere from west to east in a westerly direction in a circumpolar manner. Like if I have to show you by the diagram, that such kinds of winds that are flowing at high altitude around the polar region in a circumpolar manner. They move around the polar region in very narrow concentrated bands. So these winds, high altitude winds, are known as jet streams. The name is jet stream. The name itself provides the definition, the key characteristics of the definition. One is that these winds are jets. They are high velocity winds. Then these winds are streams flowing in a narrow concentrated band. Where do these winds flow? In high altitude. In which direction do these winds flow? Usually from west to east. In which manner do they flow? They usually flow in a meandering path, serpentine path. And where do they flow? In a circumpolar manner. They move all around the polar region from west to east. So these are the jet streams. And usually in general, jet streams are meandering in nature. They follow a serpentine path. But this meandering tendency increases or decreases depending upon the season, depending upon the temperature conditions, temperature contrast, and all those things. So Rossby waves is the name that we give to the meandering jet streams when their meandering tendency is more. So the scientists at Indian Institute of Science, they found out that probably Rossby waves or the disturbances created by these meandering jet streams are probably responsible for declining rainfall in India during non-El Nino years. there is this one statement, complicated statement that they have given over here. We'll try to simplify this statement, we'll try to decipher this statement. I'll read this statement out for you. This is the statement that you would experience in all the newspapers and all the magazines, and there is no much explanation given in those newspapers. So we'll be deciphering this very statement only in our class. Winds in the upper atmosphere are interacting with a deep cyclonic. The point to be noted, winds in the upper atmosphere. Whenever we talk about the air circulation, we must know whether we are talking about the surface circulation or we are talking about the upper air circulation. Over here we are talking about the upper air circulation. Even jet streams are high altitude, upper atmospheric winds. Winds in the upper atmosphere are interacting with a deep cyclonic circulation. Deep cyclonic circulation, low pressure. What is the cyclonic circulation? By now you are very well versed in this thing that cyclone is any circulation around a center of low pressure above the abnormally cold North Atlantic waters. Again, in the polar regions. The resulting wave of air currents called a Rossby wave curved down from the North Atlantic, squeezed in by the Tibetan Plateau. An air wave, low pressure cyclonic circulation generated from the Rossby waves and pushed in towards, squeezed in towards the Tibetan region just to the north of India, hit the subcontinent around mid-August, suppressing the rainfall and throwing off the monsoon. This low pressure cyclonic circulation, cyclonic disturbance from the North Atlantic region, with the help of Rossby waves, it gets sucked in towards the Tibetan region around the month of August, around mid-August, and this low pressure cyclonic circulation suppresses the monsoons in India. So that was the explanation that was given by the scientists at Indian Institute of Science. And with this, I'll come to the details of this explanation, but one thing that one takeaway that we can have as a result of this research is that earlier, whenever we were trying to explain the monsoon phenomenon in India, we would concentrate our discussions on Indian Ocean region. Then we got to know of El Nino phenomena and its impact on the Indian monsoon. We expanded this explanation to include Pacific Ocean as well. So whatever happens in Indian Ocean and Pacific Ocean, it influences the monsoon scenario in India. But with this explanation, whatever happens even in the Atlantic Ocean, in the North Atlantic Ocean, even that is affecting the drought scenario or the rainfall scenario in India. So we must expand our definition, expand our focus to all the global phenomena so that we can properly understand the monsoon. This would help us in better predict the monsoon patterns. When would the drought take place and how much would be the rainfall, whether it would be excess rainfall year or the deficit rainfall year. If we want to predict monsoons in a better manner, we must take into consideration all the factors that influence the monsoons. So this will help us in better understanding the monsoons so that we can predict the monsoons in advance in a better manner and we can be prepared. Now I come to the explanation part of it. What are the Rossby waves? Like I told you earlier, the meandering jet streams are called Rossby waves. How are they caused? They are formed when polar air moves towards the equator while the tropical air is moving polewards. Goes without saying that the air around the polar region would be relatively cool, while the air in the equatorial and the tropical regions would be relatively warm. So when the cold air from the polar region tries to move towards the equator, or the warm wind from the tropical region tries to move towards the polar regions, it results in a meandering wave of winds, meandering jet streams, which are known as the Rossby waves. If this meandering increases to such an extent, what would happen? Eventually, like this was a relatively relatively straight, not exactly straight, but relatively more straight path of the jet streams. Here the meandering starts because the warm air starts pushing upwards and the cold air starts pushing southwards. This meandering tendency has increased in this diagram, and the next stage would be when meander has increased to such an extent that a portion of the air is completely detached from the main jet stream. Here a warm portion gets completely detached and starts moving towards the polar regions. Here the cold air parcel, it completely detaches itself from the main jet stream and starts moving towards the equator. One of these cyclonic circulations, it moves towards the Tibetan region and suppresses the monsoon in India. That was the explanation that was given by Indian Institute of Science. Now we'll try to visualize the same thing from this diagram as well. This was the side view diagram. Now this is the top view diagram. We are observing the same situation standing on the North Pole, standing right above the North Pole. If we'll observe this situation from this diagram, what we will observe that a band of winds is moving in a circumpolar manner around the North Pole. These winds, they are moving in a slightly meandering path. But if the cold air would push towards the equator or the warm air would push towards the poles, what would happen? The meandering tendency would increase. The meandering tendency would increase. What would be the extreme form of this? The meandering tendency increases to such an extent that a portion is almost detached from the main jet streams. And the final stage would be when a low pressure center, a cyclonic circulation, completely detaches itself from the jet stream and starts moving towards equator. Now, one of these detachments, again, like I said over here also, one of these detachments, one of these low pressure circulations, one of these cyclonic circulations moves towards the Tibetan region and suppresses rainfall in India. Now, how does that happen? I think this part of the explanation is clear, that when meandering tendency increases to such an extent that a portion of the cyclonic circulation, it gets detached from the main jet stream and starts moving towards Tibetan plateau, it suppresses the rainfall in India. Now, how a cyclonic circulation that moves towards the Tibetan region is able to suppress rainfall in India? Now, for that, we must come to this diagram. That a cyclonic circulation is moving towards the Tibetan region and is suppressing rainfall in India. First of all, I had made it clear right at the outset that whatever discussion we are having the discussion with respect to the upper atmosphere. And there is this one basic rule of climatology that we had discussed while we were discussing the class on tropical cyclones, that the upper air circulation is always of the opposite nature as compared to the surface circulation. If on the surface winds are blowing in a westerly manner, in the upper atmosphere winds will be blowing in the easterly manner. If on the surface you are experiencing high pressure, on the upper atmosphere you will be experiencing low pressure. If on the surface you are experiencing cyclonic circulation, in the upper atmosphere you will be experiencing anticyclonic circulation. If on the surface you are experiencing converging air, on the upper atmosphere you will be experiencing diverging air. This is a basic rule of climatology, that whatever happens on the surface is the exact opposite of whatever is happening in the upper atmosphere. Clear? So when I say that, like in the previous diagram, when I had been saying that a low pressure center, it detaches itself from the main jet stream and moves towards the Tibetan plateau. Am I talking about the surface circulation or the upper air circulation? I am talking of the upper air circulation. A low pressure center, a low pressure cyclonic circulation detaches itself from the jet stream and moves towards the Tibetan plateau in the upper atmosphere. What would be the situation at the surface? At the surface, it would generate high pressure conditions. So you have to keep this thing in mind. I'll come to this aspect later. First of all, let us understand how monsoon rainfalls take place. How is it that the monsoon causes rainfall in India? They are able to cause so much rainfall in India. The very basic explanation for monsoons, that's the classical concept or the thermal concept of the monsoons, is explained by a temperature contrast between the oceans and the land masses. During the summer season, the land masses gets excessively heated up, and they are at relatively, this entire Central Asian region including the Tibetan Plateau, it is at high temperature, relatively high temperature as compared to the oceans. Oceans are at relatively, the Indian Ocean is at relatively low temperature during the summer season as compared to the land. Now, if this is the temperature scenario, what would be the pressure scenario? You know that the temperature and pressure, they are inversely related to each other. If there is high temperature over here, of course there would be low pressure over here. If there is low temperature over here, it would result in high pressure over here. So oceans are at relatively, Indian Ocean, this portion of the equatorial Indian Ocean is at relatively high pressure as compared to the Tibetan Plateau region. This creates a pressure gradient. Winds always flow from high pressure to low pressure, and this is what that sucks in, that attracts monsoonal winds from the Indian Ocean region into the Indian subcontinent. And when these moisture laden monsoonal winds strike India, they cause rainfall in India. So what sucked in the monsoonal rains from the Indian Ocean? It was this low pressure that developed over the Central Asian Tibetan Plateau axis. Now in this explanation, I believe when I was talking about the low pressure and when I was talking about the high pressure, when I was talking about the oceans are at relatively low temperature as compared to the land masses, it goes without saying that I was talking about the surface temperature. What is the temperature of the water and what is the temperature of the air just above the water? What is the temperature of the land and what is the temperature of the air just above the land? So this scenario that we have discussed right now, it's with respect to the surface circulation. That what is happening at the surface level, near the surface level during the summer seasons, that winds are flowing from the Indian Ocean region to the Indian subcontinent region because of the pressure gradient between these two poles. More the pressure gradient, more would be the strength of monsoons, better would be the rainfall in India. If the pressure gradient is not sufficient, then monsoonal winds would be slow and there would be insufficient rainfall in India. So that's the general explanation. Now what is important? How do I relate these two things? Now this is something that we had been studying about monsoons in our 8th, 9th classes as well, since our 8th, 9th classes as well. But how do I relate this explanation of monsoons with what was given by the researchers at the Indian Institute of Science recently? The Rossby Waves explanation. According to that explanation, a low pressure cyclonic circulation moved from the North Atlantic waters, cold North Atlantic waters, and moved towards the Tibetan Plateau. But in that explanation, I had specifically mentioned that I am talking about upper atmosphere. If there is low pressure circulation in the upper atmosphere, what would be the nature of circulation at the surface level? It would be a high pressure circulation at the surface level. Now you know that the surface circulation and the upper air circulation are of opposite nature. So if a low pressure center is moving at the upper atmospheric level, you can very well say that a high pressure center is moving at the surface level. Now here is the low pressure at the surface level. the existence of low pressure ensures that monsoonal winds are sucked up and they cause rainfall in India. What if this low pressure center gets destroyed? What if there is no low pressure over here? Then monsoonal winds will not be sufficiently sucked up. And that's the role of the Rossby waves, or the low pressure cyclonic circulation that gets detached from the Rossby waves. This high pressure center at the surface level, it negates this low pressure center that has been created at Tibet. It nullifies the effect of this low pressure center. So if there is no low pressure center, there would be no pressure gradient and the monsoonal winds won't be sucked up and there would be insufficient rainfall in India. And because this circulation hits the Tibetan region around mid-August, that's when the rainfall declines. We had covered it in the characteristics of a non-El Nino drought, that rainfall recovers during mid-July to mid-August period, but then it starts declining after the mid-August period, from the late August onwards. Because this cyclonic circulation, upper air cyclonic circulation, strikes the Tibetan plateau around late August, that's when the decline of monsoons sets in India. So I hope the explanation regarding the declining rainfall during non-El Nino years attributed to the Rossby waves is clear to you people. Then, like over here, they have explained the same thing. Now, moving on to our next topic, Paris Agreement and India's targets. Paris Agreement, like I said earlier, is the overarching agreement. You know about that. In 2015, it was signed by all the parties. And under this agreement, the ultimate aim was to limit the rise of temperature of the earth to 2 degrees Celsius as compared to the pre-industrial levels. And whatever was the temperature of the earth before industrial revolution in 1700s and 50s, will try to limit the increase of Earth's temperature, increase of planet's temperature to 2 degrees Celsius as compared to that temperature, as compared to pre-industrial level. Now, there was this one more statement that there was a lot of hue and cry from the smaller nations, from the small island nations and the nations whose economy was dependent on the coastal tourism and such like things. They said that 2 degree temperature rise is way too much to cause so much disaster in their territories. Their economy would be destroyed, their ecology would be destroyed. So why don't you keep a more ambitious target? But this was the target that was chosen, that will try to limit the rise of Earth's temperature to 2 degrees Celsius. And along with this, there was this vague statement that said that, but will try to limit the increase in temperature to 1.5 degrees Celsius. So that was the ultimate aim of the Paris Agreement. What was the process that was adopted by the Paris Agreement, parties to the Paris Agreement? We have discussed about that earlier as well, that different parties, they were supposed to declare their own nationally determined contributions. There was no central body that was supposed to dictate to different participating countries that, okay, you will decrease your emissions by this level, you will decrease your emissions by this level and this level. Like, there was no central body to decide such matters. Every country, every nation was supposed to determine this on its own, nationally determined contributions. And like as a consequence of that, different countries, they gave their nationally determined contributions. In the first round, 186 parties submitted their first NDCs, while 2 countries have even submitted their second round of NDCs. So almost all the participating countries, they had delivered and they had given their nationally determined contributions. But here was this yet another drawback of the Paris Agreement, that even though the countries party to the Paris Agreement, they were supposed to discuss the performance of the other countries, but there was no provision of sanctions or penalties. Suppose I declare that I will reduce my emissions by this much XYZ level, and I am not able to do that. what action would be taken against me? Nothing. The Paris Agreement is silent on imposing any sanctions or imposing any penalties on the countries that are not able to achieve their targets. First drawback is the countries themselves, they would decide that how much contribution do they want to make. Second, that even if the countries are not able to achieve the targets that they themselves had set, there is no provision of sanctions or penalties. But that's the process that had been going on. Now, in this context, the most important body that meets frequently to discuss the progress of different countries in achieving the Paris targets, it is the Conference of Parties, COP. Actually, COP itself is a conference of parties to the United Nations Framework Agreement on Climate Change. United Nations Framework Convention on Climate Change, UNFCCC, that took place in 1992. The most important decision-making body of this overarching treaty of the United Nations dealing with the climate change is the Conference of Parties. The Paris Agreement itself was signed during the 21st Conference of Parties of UNFCCC. This COP takes place every 2 years. So the next COP is supposed to be held in Glasgow in Scotland in November 2021. But prior to that, a climate ambition summit took place in the last week, in December 2020. That was assumed to be a step to the COP26, the COP that is going to take place at Glasgow in the next year. Actually, the NDCs, the countries that had declared their NDCs in the first round, most of those NDCs, they were to be reviewed after the period of 5 years. They were to be reviewed after a period of 5 years. And the 5 years are about to expire, and now the discussions are going on that how different countries can contribute more to the control of climate change. So in this context, certain more commitments are expected from the global leaders. So in that context, Climate Ambition Summit took place in December 2020. It was co-hosted by United Nations, UK, France, in partnership with Chile and Italy, the participating countries, the host countries, you should remember. Actually, no physical summit took place. It was actually a virtual summit where different leaders from around 78 countries around the world, they participated, and it was expected that they would commit more resources for the purpose of climate change. So we'll come to what different countries committed during this climate summit. China said that it would seek to cut its emission per unit of GDP by more than 65% from the 2005 level. Actually, emissions intensity reduction was one of the targets, one of the parameters that was chosen by countries. We will try to reduce the emissions intensity of our emissions. Earlier, China had said in its first round of NDCs, it had said that it would reduce its emissions intensity by 60% as compared to the 2005 level by 2030. Now, in this summit, they had agreed that we'll reduce our emissions intensity by 65% instead of 60% as compared to 2005 level by 2030. India reiterated its commitment to increase the renewable power capacity to 450 gigawatts. Earlier, India had committed that will try to generate 175 gigawatts of renewable energy by 2022. Now we are saying that because we are well on track to achieve that target, now we are saying that we'll generate 450 gigawatts of renewable energy by 2030. Similarly, other countries, Argentina said that will achieve carbon neutrality by 2050, Argentina and Vatican City. Carbon neutrality, we had already discussed what is carbon neutrality, that the net carbon emissions are zero. The carbon dioxide that is emitted as the result of economic activities or other activities is equal to the carbon dioxide that is absorbed by the carbon sinks. the forest resources or the other carbon sinks that exist within your country, they absorb equal amount of carbon dioxide from the atmosphere as much carbon dioxide is released from your industry. So Argentina and the Vatican, they pledged carbon neutrality by 2015. Similarly, Pakistan said that will not construct any more coal-based thermal plants, and it set a goal of to achieve 60% of its power from renewables by 2030. So these were some of the commitments that were made by the world leaders at this Climate Ambition Summit. Now, before I wrap up this thing, we should know that what were India's NDCs. Just a quick revision of what were India's NDCs as it declared at the Paris Agreement of 2015. Improving the emissions intensity by 33 to 35%. I was talking about reduction of the emissions intensity. China had earlier promised that it would reduce its emissions intensity by 60%. Now it is saying it will reduce by 65%. India had promised that India would reduce its emissions intensity by 33 to 35% by 2030 as compared to the 2005 levels. Similarly, India would increase the share of non-fossil fuel-based electricity. Non-fossil fuel-based electricity to 40% by 2030. India would enhance its forest cover. India would create new carbon sinks. The sinks which would help in long-term storage of the long-term absorption and storage of carbon from the atmosphere, by absorbing 2.5 to 3 billion tons of carbon dioxide. So these were the three primary NDCs that India declared, and our environmental minister and as well as our Prime Minister Modi, he has both of them, they had reiterated that India is well on its way to achieve its NDCs. What's the present scenario? What's the India's progress as of today? India has achieved 21% of its emission intensity reduction target. We had to reduce this emission intensity by 35% by 2030 over the 2005 level. In 2020, we have already been able to reduce the emissions intensity by 21%. The share of the renewables in our energy mix is around 38%. 40% was what we promised, and we already, like by 2020, we have achieved this, we have raised the bar to almost 38%. Tree cover has increased by 15,000 square kilometers in 6 years, whereas India's renewable energy capacity is the fourth largest in the world, and it will reach 175 gigawatts before 2022. This was what we had promised, and we are saying that we'll be able to achieve this target before the deadline, before 2022. So India is performing reasonably well as far as its NDCs are concerned. And in that context, we are also discussing among us ourselves that how we can improve India's performance in this climate change action. Already our Prime Minister at the Climate Ambition Summit that took place recently, he had said that India had revised the goals. India had earlier also, we had committed to this thing that will revise our goal of renewable energy production to 450 gigawatts by 2030. So that's all as far as the Climate Ambition Summit was concerned. Now moving on to the next topic, tropical montane grasslands in Western Ghats. Now these grasslands, there are very few grasslands of such kind found all over the globe. Just 2% of the world's grasslands. Tropical montane grasslands are high elevation grasslands, forming only 2% of all the grasslands of the world. Tropical montane grasslands, the grasslands that are found in the mountainous, high elevation regions in the tropical areas. They are known as the tropical montane grasslands, and they are just 2% of all the grasslands, all the other grasslands that are found in the world. Usually we hear about the temperate grasslands, or we hear about the tropical savanna type grasslands. Tropical savanna type grasslands are low altitude grasslands. we don't often hear of this tropical montane grasslands because they constitute only 2% of the total grasslands in the world. But in India, they are found in the Western Ghats region, in the Nilgiri mountains, in the Cardamom hills, in the Anayamalai hills. In the Western Ghats region, these grasslands are found. Now, why they were in news? These grasslands, they are getting destroyed as a result of invasion by exotic trees. How is a grassland landscape different from a forest landscape? Like the very name tells us the difference. In a forest landscape, you'll have so many dense trees growing close to each other and it will support a rich biodiversity. On the other hand, grasslands, they would tend to have less trees and more of the grasses. And the biodiversity supported by these grasslands would also be relatively less as compared to the biodiversity supported by the tropical forests. But that does not mean that these grasslands, they do not support any biodiversity. They support their own unique biodiversity, own unique flora and fauna. But what is happening as a result of this study that was conducted by IISER Tirupati, Indian Institute of Science, Education and Research? This study says that the tropical montane grasslands in Western Ghats, they are getting degraded primarily due to invasion by the exotic trees. Trees like eucalyptus that are grown for their timber, trees like acacia, trees like other pine trees, cheer pine trees that are grown for their timber, for their wood value. These trees are being introduced to the grasslands landscapes, and because they are artificially introduced, the plantation of these trees is being done. That's leading to degradation of the grassland landscape. This thing needs to be reversed. The study pointed out that there is very little protection is accorded to grasslands in India. In general, not even the tropical montane grassland. In general, the study highlighted that very little protection is accorded to grasslands in India because we feel that because they are not yielding timber, they are of less value or they support less biodiversity as compared to forests, they require less protection. So in our official records, again, one of the more things that was highlighted by this study, in our official records, we are classifying the grasslands as wastelands. If a particular piece of land is classified as wasteland in the Sarkari records, how much protection do you think would be accorded to that piece of land by the government authorities? Very less. So they say that we need to restore grasslands. Grasslands have their own ecological function. They support unique flora and fauna. They play an important role in maintaining the hydrological cycle, in maintaining the ecological balance. They help in the groundwater recharge. They help in the flood control in the Nilgiri regions. So we must restore the grasslands, the tropical montane grasslands in the Western Ghats region. Now, in this respect, how to restore the tropical grasslands? Now, difficulties in conservation I have already explained to you people. Okay, how can we restore these grasslands? So in this context, these researchers, the same study, it had identified the areas which are suitable for grassland restoration, and this was done using high-tech satellite imagery techniques. They focused on identifying grasslands using satellite images with high spatial resolution, the technique that they called rapid eye. And what was to be first step is identification of the areas that can be restored. What's the problem in those? What was the original problem? That grasslands have been degraded on account of introduction of exotic trees. Now, what are we supposed to do? Are we supposed to remove those trees? They say that you need to make a distinction. If there is, if because of human activities, because of the plantation, because of whatever reason, if a very dense forest has resulted into being, then leave that area apart. That was the purpose of satellite imagery, rapid eye technique, that we would identify whether the grassland region had turned into a completely forested landscape, then we'll leave that area apart. But if there are just a few isolated trees growing in the grassland region, then the research had recommended that those young trees, they can be removed and transplanted somewhere else. Only then they will be able to restore grasslands. they have recommended careful removal of young and isolated exotic trees at the invasion front and restoring the grasslands. Now, what areas they had identified? The areas that they had identified, they were primarily situated in the Nilgiri mountain range, Palani Hills mountain range, and the Annamalai Hills mountain range. So these were the three areas that they had identified for grassland restoration. Let's have a look at the map where these hills are located. In the extreme south of India, the highest mountain peak of South India is Anai Mudi over here in the Anaimalai Hills. Anai Mudi in the Anaimalai Hills on the tri-junction of Kerala, Karnataka and Tamil Nadu. This Anai Mudi is not only the highest peak of South America, but it is also a knot. We use the term knot in case of mountains to refer to a point from where multiple hill ranges originate. From this Anai Mudi, if you go north, you have Nilgiri Hills. If you go south, you have Anaimalai Hills, the very range where this Anai Mudi is formed. Anai Mudi Hill, Anai Mudi Mountain is a part of Anai Mudi range. Anaimalai range, sorry. And to the northeast of it, you have Palani range. So Nilgiri Hills, Palani Hills, Anaimalai Hills. And even to the further south of Anaimalai Hills, you have Cardamom Hills. Cardamom Hills are not mentioned over here. They have not identified this region for the grassland restoration. They have identified Nilgiri Hills, Palani Hills and the Anaimalai Hills as the regions for grassland restoration. So you must keep the location of the hills in mind, the Western Ghats region and the extreme south of the hill ranges of the extreme South India. Next topic, again we are moving to the prelims related updates. No significant aspect from your mains point of view as far as these two news items would be concerned, this and the next one. Kerala to open a wildlife rehabilitation facility. Earlier, we have been experiencing increasing instances of man-animal conflict. Because of that, so many animals they get injured or such like things. In Kerala, there was no facility to treat those animals, no state-of-art facility to treat those injured animals. They used to be sent to be far-off places. For example, we had this one facility in the Mysore Zoo, Shri Chamarajendra Zoological Gardens in Mysore, one of the best zoos in India, one of the largest zoos in India. It already had this facility, wildlife rehabilitation facility to treat tigers, leopards, sloth bears, wild dogs and other large animals. But Kerala had no such facility. So the animals which got injured as a result of man-animal conflict or as a result of natural factors, they used to be transported to far-off places for treatment. Now Kerala government has decided to set up this rehabilitation facility in the Thrissur region. So that's one point that you can keep in mind. The last news item that we'll be covering is regarding the Kaziranga National Park and Tiger Reserve. Kaziranga National Park is the best known habitat of great Indian one-horned rhinoceros. It is not only known for rhino conservation, it is also known for elephant conservation and the tiger conservation. Rhino conservation to hai, yeah? Like more than 2200 rhinos, that's more than 2/3 of the total population of the great one-horned rhinoceros of the world. It's found in Kaziranga National Park. Apart from these animals, Ganga River dolphins, they are also found in the Brahmaputra region of this national park. And it's also a UNESCO World Heritage Site. UNESCO identifies cultural heritage sites as well as the natural heritage sites. So it is one of the UNESCO Heritage Site as well. Now, why it had been in the news? It was in the news because now the government plans to introduce boats and the bicycle treks within the Kaziranga National Park. It is trying to promote ecotourism activities in the buffer zone. Every tiger reserve, it is based on core buffer strategy. While no human intervention is allowed in the core region, the buffer region allows certain human intervention, for example, the research-based activities or the ecotourism activities. And it is in this context that we can now explore Kaziranga National Park on boats as well as on the bicycles. So that was the news item. We can see over here some of the important national parks and wildlife sanctuaries of the Assam region. That over here on the border of Bhutan and Assam is the Manas National Park, Manas Wildlife Sanctuary, Manas Tiger Reserve, again one of the very famous tiger reserves of India. And then you have the Orang National Park on the northern bank of river Brahmaputra, and you have the Kaziranga National Park on the southern bank of river Brahmaputra. Then yet another very important national park and tiger reserve, Dibru-Saikhowa National Park and Tiger Reserve. So these are like some of the national parks that you can remember as far as the state of Assam was concerned. So that's all as far as this week's current affairs are concerned. I hope you would have enjoyed the video. Keep watching our videos for more such content. Thank you so much.